Hello, this is the 2023 Oxford PAT. So what we got here, 26 questions, calculators allowed, looks like the same sort of thing. I'll do the multiple choice questions in this video, of which I expect there'll be 12. Question 1. What speed does a bull elephant mass of that have to move at to have the same kinetic energy as a cyclist mass of that moving at 30 kilometers per hour? Right, what's the catch on this? This seems too easy. Right, okay, the catch is they've changed the unit, so they might be catching people out. They've gone from kilometers per hour to meters per second in the answers here. So, right, well, let's do, first of all, we're going to have, well, let's leave out the halves. So 100 times 30 squared is going to be 4900 times v squared, where that's going to be in the kilometers per hour. So that's giving us, let's get rid of that, and that. So we can square root, that's going to be 30 over 7, isn't it, for v in kilometers per hour. So we just need to flip this over into meters per second. So we're going to have to, what are we going to have to do? We're going to have to multiply this by 1,000 over 3600, and then that's going to give us what we want out of all of this. So just trying to find where the calculator is, that's why I'm stumbling around. I should have picked that out before I started. So we've got 30,000 divided by 7 is that, divided by 3600 gives 1.2 meters per second. Right, so yeah, I suppose if you had not spotted the unit change, what are they trying to tempt you into? It's not far off of C, is it? 30 divided by 7. Yeah, so they're trying to sucker people into picking a C rather than a B on that one. Anyway, question 2. A seed packet contains 100 seeds. When planted, 75 will become plants. Right, so we've got 100 seeds. Then we've got 75 plants. A third of these will have flowers, so that's going to be 25 have got flowers. And of these, only 1/5 will produce fruit, so 5 will produce fruit. How many seeds produce fruiting plants? Well, 5. Right, that's that one. Question 3. 2 black holes orbit each other and emit gravitational waves arising from the periodic nature of the orbit. Right, okay, we've got some new ground here. The orbital separation is around 10 kilometers. The relative speeds of the black holes are close to the speed of light, and the gravitational waves travel at the speed of light. Which of the following will best describe the frequency of the emitted radiation? Right, well, this is a topic that we don't know very much about, if anything. So we've got these 2 black holes. Orbital separation is around 10 kilometers. So these are orbiting around each other. And we've got this 10 kilometers apart, so they're going to be going through this circle. They're going to be orbiting the center of mass, and the frequency is going to be to do with the frequency that they're going round and round in this circle. This is the only periodic thing that we've got going on. So let's then do, well, they're orbiting each other, so yeah, so let's then do that t. So this is going to be the orbital period. That's what we're going to base our frequency on. So it's going to be 2 pi r divided by, well, they're moving close to the speed of light, so let's just say that's c. So that is going to be pi times 10 to the 4, our 10 kilometers, divided by 3 times 10 to the 8, and that's going to be our 1 over the frequency. So what have we got on that? We've got more or less 3 times 10 to the 8 divided by 3 times 10 to the 4 once we've taken the reciprocal. So we've got about 10 to the 4 hertz, give or take. It's certainly, well, they're doing big jumps here. They're going up in steps of 10 to the 3. So 10 to the 4 is certainly the closest one that we're going to get. So yeah, trying to throw people with something that's unfamiliar there. Question 4. What is the next number in the sequence? Right, we've got things that are 1 less than powers of 2 on the top. I mean, the one that's odd is that one where they've dropped it down. You'd expect that to be what, a 15 that they've divided by 5. So yeah, on the bottom we've got multiples of 5. or powers of 5, I should say. So this would have been a 15 over 625, but they've taken a factor of 5 out of top and bottom. So we're going to have 63 over 3125 times 5, which is going to, well, there's only one that's got 63 at the top, so that's going to be E. Okay, consider a pulley system, or we like pulley systems, containing 4 wheels. If you pull the free end a distance y, how far will M raise by? Right, well, we've got 1, 2, 3, 4. So 4 ropes means we've got a mechanical advantage of 4, so we're going to move by a quarter of the distance in order to conserve energy. So we want y over 4, which is B. If you're not that familiar with pulleys, admittedly I'm biased towards my own videos, but go and watch my Simple Machines video on pulleys. It'll tell you everything you need to know. Question 6. Consider f of x equals x squared. You want to transform the function so you get a new function, g of x, stretched by a scale factor of 2 with a line of symmetry about x equals 1, which is never positive. Okay, right, so there's a lot of things. Well, never positive, right, so we want to flip it over. Line of symmetry about x equals 1. Right, let's draw out what we've got. Right, we've started with this. That's our y equals x squared. And we want to end up with something which is never positive, line of symmetry about x equals 1, and has been stretched as well. So we want to do that. We know we've got to, so we've got to move it 1 to the right, which means we're going to get an f of x minus 1. We need to flip it over, and we need to stretch it in the y direction by 2. So we need to multiply by minus 2, which means we're going to get A. Okie dokie. And onwards to question 7. If y equals that, which of the following is dy dx? Right, so, well, differentiate it, we'll get 4 over 2 plus x over 2 cubed. So we've got 2 times summing. Fortunately, they've given us very different numbers on all of these. So we're going to have a 16 so it's already looking like D. So let's check our cubes. That will be 2 times an 8th, so a quarter of x cubed. So yeah, D. That's good. Flying through these at the moment. All resistors in the circuit below have the same value. If an ammeter is placed in the circuit in turn at points A through to E, which of the following sets of points will give the same reading? Right, so we're going to have to work out how if our EMF is V, how we split in this across each branch across here. So we've got, well, it's going to be split in proportional to resistance. All the resistors are the same. So we're going to have a half to a quarter to, oh, that is also going to be a half as well. With these, you can either go through the formula, but on that last branch, you'll see if you combine the bottom two, like these two double resistors here, then that's going to reduce down to a single resistor because you're halving them because they go in parallel. So 2 double resistors in parallel is like a single resistor in series. So then if we've replaced those bottom 2 branches, we've got exactly the same as the setup here with A on the left. So we're going to have the same PD across that branch as we are on the first one. Now we just have to go through doing Ohm's law on each one. I suppose we just do a V equals IR on each one. So we're going to have 2/5 of V. This is for A. So for A, 2/5 of V is going to be equal to the current through A times 1 lot of resistance. Then for B, we're going to have what we've now got 1/5 of V is going to be equal to I times R. For C, we're going to have 2/5 of V again is equal to I times R. So A and C are the same. And then D, we've got 2/5 of V is equal to 2 lots of I times R. So that's going to mean that B and D are the same. E we don't have to worry about because E can't be the same as any of these because E is the total current and all the others are on branches. So we got A is equal to C and B is equal to D on this. So let's see what we get here. All right, okay, so they've got, Oh, they've left out the BD one, but we have got A and C. So we got B going on there. Right, if dy dx is that, y is that, when x is that, what is that integral there? Right, okay, so we've got then the, well, integrate the first time, we're going to have y is equal to x cubed over 3 minus x, well, minus 2 over 2 plus c. So y is 0 when x is 1, so that's a third minus a half plus c. So c is going to be a sixth. C is 1/6. Then we need to integrate again. Right, okay, so we've got y is equal to, well, we want to do the integral from 1 to 3. Let's just leave that bit out. Of x cubed over 3, 1 over 2x squared plus a sixth dx. Right, this is more work than we've had to do on the previous questions. So x to the 4 over 12, that's now going to become a plus 1 over 2x plus x over 6. 3 to 1. Just scroll a little bit down. So what have we got there? That's going to be 81 over 12 plus a sixth plus a half minus a 12th, then minus a half and minus a sixth. So they all disappear and we're left with 80 over 12, which is 20 over 3, which is C. So that was a straightforward question. It took a bit of working out, but it was pretty easy. A particle of mass m travelling freely at an initial speed v can be stopped in a distance d by a constant retarding force F. Right, okay, that's a lot to take in. We'll go back to that sentence in a minute. What magnitude of force applied in a direction perpendicular to motion would be needed to change the trajectory of the same particle at the same speed v into a circular arc of radius d? Right, so we're stopping, well, we got a force times the distance is the work done. That's the energy transferred, which is a half mv squared if it's been brought to a halt. So that is our F. What magnitude of force would be needed to change the trajectory of the same particle into a circular arc of radius d? Right, so our F2 then, if we're moving in a circle, we need an F2 will be mv squared over r, and r is d. So mv squared over d, if we rearrange this, we can get mv squared over d equals 2f. So F2 must be 2f, which is E. Right, that was just really an exercise in unraveling those sentences, which were a little convoluted. What is the integer m such as the sum from n is 1 to m of that equal to 140? So, right, what are we getting here then? We're getting, well, we got it in 2 bits. We've got 3m is 1 bit just from adding up 3 m numbers of times, and then we've got 2 to the n, so that is going to be, but not 2 to the n, 2 multiplied by n going up to m. So we're summing up the numbers 1 to m and then we're doubling it, so we need twice the mth triangular number. So that's going to be m plus 1 times m over 2. So we just need to solve this. That's obviously going to cancel with that. So we've got m squared plus 4m equals, what did they say, 140. So we're going to, well, we could try, well, you can see it's going to be 10. We don't even need to go in, and we've got 100 plus 40 is 140. So C. Okay. Question 12, which I think is going to be the last multiple choice one. It usually is. The device uses 3 kilowatts of power at voltage of 60 volts. Right, so if we've got, so we've got 3000 watts divided by 60 volts, that's going to give us the current, which is going to be 50 amps. Is connected to a power supply via an ideal transformer. The transformer has n turns on the winding connecting to the device and 20 n turns on the power supply. So we've got 20 n. This is on the supply. It's supply, if I can write it. and n turns on the device. We've got 50. What current flows in the winding connecting to the power supply? So we've got 50 amps there. When you drop down the number of turns, you step up the number of amps. So this is going to have to be 50 divided by 20 amps. So it's going to be 2.5, which is C. Then is that the last one? Yeah, that is the end of the multiple choice questions. Right, they seemed straightforward to me, which is often a dangerous thing to say because it probably means I've made a stupid mistake in one of them. But I think with the exception of the black holes one that came early on, there isn't really anything that unfamiliar in these. So assuming I haven't done anything daft or fallen into any of the traps that sometimes they lay in these questions, that seems like quite a nice opening bunch. So, yep, leave that there and I'll be back with the next bunch soon.